Hello, 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 and welcome to another Bindplane SecOps workshop. This time, as always, I have Denton and I have Ryan with me. I'm super happy to see you. First, of course, sign up and then, of course, join us here in such a I'm gonna say very impressive number. So the whole team is super happy to see so many of you joining us once again for our April edition of the Bindplane hands-on workshop with Google SecOps. So I'm your host for today. I'm Adnan, and I'm the developer relations lead here at Bindplane. With me today, I just want to first introduce Denton and Ryan from our product team. First, Denton, go ahead and introduce yourself.
Yeah, I'm Denton, sales engineer here at Bindplane. I'm going to be leading the demo today. Excited to be with you all.
Hey everyone, I'm Ryan. I lead product here at Bindplane. Thank you all for joining. I'll be answering Q&A during the first half, so fire away. If you've got any product feedback, feel free to drop it in there as well. Absolutely email me feedback or find me in Slack and DM me anytime. Would love to hear what you think of Bindplane and how we can continue to improve the product for you.
Awesome. And yeah, as Ryan said, feel free to drop questions right away. There's no need to wait until the Q&A at the end. If you have any questions, just throw them in the Q&A, and we're happy to either answer right away via text, or we'll just take a break and answer your question live in the workshop itself. So yeah, so let's just dive right in. Going through the agenda for the first, let's say, first couple of minutes here. So there are three main things that we are going to go through. So first, we'll introduce Bindplane and all of the core features, so you know exactly what Bindplane is, for anybody that maybe hasn't been to any of our past workshops. We'll also do a Bindplane architecture diagram. So we're going to do a deep dive into the architecture and how everything works together. We're also going to talk about the op-amp protocol a bit, and that's basically the bread and butter of how Bindplane communicates with agents or collectors in this case. We're also going to do, well, we say we, but it's mainly Denton and Ryan and I taking a back seat and answering questions. Denton is going to do a very hands-on demo with using Bindplane and Google SecOps. And then, of course, at the end, we'll just culminate everything via a Q&A. Of course, if you do miss any parts of the demo, there will be a recording on our YouTube channel tomorrow. So don't worry about missing any parts, or if you have to drop early because of other meetings or work, do feel free to check out the video tomorrow. We're going to send everything out, and you don't have to worry about missing anything. And then moving forward, let's just jump right into the what is Bindplane section right here. Bindplane, first and foremost, it's an OpenTelemetry native telemetry pipeline. So what does that mean in this context? The core functionality is to provide a unified platform where you can route, monitor, and manage all of your telemetry, and make sure that it's going from a mass of different sources and reaching tons of different destinations the way you want it to happen. So essentially, it makes it super, super easy to collect telemetry data, process it, and then at the end export it to whatever destination you want, because it's built on OpenTelemetry vendor agnostic standards. So that's essentially our goal here. It's simplifying the way of managing a fleet of collectors. So we want your telemetry infrastructure to be much easier to manage at scale. And then, of course, all of this boils down to cost efficiency as well. Everything I just mentioned, it makes it super, super easy to use processors to reduce data, filter data, do whatever you want with your data. And then obviously make sure that you know exactly what amount of telemetry you're exporting, that you can save on the storage costs of that telemetry. And then how this ties into the Bindplane editions. I'm going to hand it over to Ryan for a second to go through which editions of Bindplane you can use and how to use them.
Yeah, so we've got a few different editions of Bindplane available. So first off are Google editions of the product, which we've partnered closely with Google to offer these. And if you're a Google Cloud Observability or, of course, a Google SecOps customer, um, Bindplane Google Edition is going to be available to you. And so that version of the product is meant to help you collect all of your telemetry, route it to any Google destination, and enrich and standardize the data in the pipeline. The enterprise version of our Google edition of Bindplane, that's essentially our fully featured enterprise offering. This is available to SecOps Enterprise Plus customers only, and this adds advanced data reduction capabilities. And so as you start to think about how you're going to optimize your telemetry and reduce volume, this version of the product is going to work great for you. Once you want to start to send data to other destinations, you're going to want to look at Bindplane Enterprise, and we can help you with that, and that's going to let you send to other non-Google platforms.
Awesome. Thank you, Ryan, for the deep dive on editions. And then from here, I just want to do just a brief little overview of the architecture so that everybody's on the same page on how it works. This is a very it's not a rough, but it's not that elaborate, but it's a quite elaborate architecture overview of what it would look like to use Bindplane Cloud. This is the same thing for self-hosted Bindplane as well. It's just you would be hosting it yourself. The key components here include the middle part, which are the collectors. They're responsible for gathering telemetry data from all of your different systems. Then on the left side is the control plane, and that essentially acts as a central control plane for managing and monitoring all of your collectors. And then the communication between them happens through the op-amp protocol. Now, the middle part, the collectors, what happens here is that Bindplane helps manage all of the telemetry throughput efficiently by making it super simple first to configure and set up all of your multitude of collectors that you have. Since it's OpenTelemetry native, it also supports collection primarily because we have a Bindplane distro for OpenTelemetry Collector, as we call it. So it's a B.dot collector. That's our upstream version of the official OpenTelemetry Collector, just some sprinkled in magic with op-amp. And you're going to learn a bit more about that in a second here. The fact that you only need to run one single install command to install the B.dot collector, that's also one part of the sprinkled in magic that we provide. And then obviously, if you want to bring in your own collector, so if you want to build your own collector, we also recently pushed out an open source tool called the OpenTelemetry Distribution Builder, and that's going to simplify the process of enabling op-amp in basically any homegrown collector that you want to build. This also ties into the fact that with Bindplane, we support managing 500,000 collectors, and that number is only growing as of today. The collector also supports more than 80 sources, 40 destinations, and then you can obviously receive and export telemetry from any multitude of sources and destinations at the same time. You also have a persistent queue in the collector, so it will cache events if some data exporting fails or telemetry exporting fails. And then, of course, I think the kicker here is that the B.dot collector is the first collector distribution to feature op-amp support built in from the get-go. And the op-amp protocol, that's the thing that Bindplane uses to communicate with collectors and vice versa. So that's how the collector communicates back to Bindplane what's happening. If you prefer using any of your own distributions with the OpenTelemetry Distribution Builder to roll your own collector, that's perfectly valid. We essentially don't want to force you to use the B collector. The B collector is just the easiest way to get started. And then if you want to change to your own homegrown collector, you can just, build your own and with op-amp support, of course, and then have it work as a drop-in replacement. And then the op-amp protocol in itself is designed for managing huge fleets of collectors. So it enables centralized updates. That's a big thing. Enables pushing out configs to collectors remotely, and it enables monitoring your collectors. The way this works is it's an inside-out connection, so to say. So the collector itself initiates the op-amp connection with Bindplane from the inside. So telemetry never really flows through Bindplane. Bindplane is just a control plane. Because this is a WebSocket connection, once it gets connected or basically open from the inside out, it stays open. So you only really need to open outbound ports from your network. And then because it's a WebSocket connection, it just stays open. So that this is better for security. You have less stress on your firewall. And these ports for using Bindplane Cloud specifically for this sample that Denton is going to show is 443 for TLS. And then if you're using self-hosted, it's 3000 or 3001 to be precise. And that's it. This also makes it super easy to migrate your collectors from Bindplane Cloud to on-prem because you just change the op-amp endpoint where you're telling the collector to communicate with the control plane. And as I said, Bindplane only shows you a preview of your telemetry that's flowing through your network. So basically anything that's happening, it's just a snapshot. No telemetry is stored in Bindplane. Telemetry only flows through the collectors, so it only flows through your infrastructure and your collectors. The snapshots that we provide in Bindplane is just an easy way to make transformations simpler. So you can essentially see exactly what's happening before and after once your transformation changes your telemetry in any way you want. This is stored in the browser cache. It's also not stored persistently anywhere. So this is a big thing for if you have security requirements like GDPR. We don't really store any telemetry, so no sensitive data is stored with us, which is also a huge benefit for many people, not just in Europe, but worldwide. And I think, yeah, the final kicker before I leave it with Denton for a hands-on demo is that Bindplane lets you remotely push out configs to your collector. But you can also, once you visually set up your config for your collector, you can also download that file. You can put it into whatever Git or GitOps flows or whatever GitHub, if whatever basically your team is using, you can leverage existing pipelines after you've actually visually created the configs. So that's an additional really like quality of life improvement that I think we've needed for a long time in the community, essentially, that Bindplane provides. Yeah, I think we can hand over to Denton for the actual hands-on stuff, and I can go into answering questions.
Awesome. Thanks, Adnan. All right, so we've got a lot to get through today. If you've seen any of our past webinars, we're going to follow a very similar pattern. We're going to start from scratch. So we're literally going to spin up a brand new Bindplane Cloud instance. We're going to install the Bindplane collector onto a couple different servers, both a Windows and a Linux server. And this is a question that has come up in the past. We get asked quite a bit, so we thought it was finally time to showcase it in one of our webinars, and that is how to set up the Bindplane Gateway, right? And this will make more sense. You saw it in the architectural diagram, and you'll see sort of how that flows in the pipeline here in just a bit. And then we're going to introduce a brand new source, which is the event tracing for Windows source. This was just recently added to Bindplane. We're really excited about it. It unlocks some new telemetry data that was more challenging to get to in the past. So like I said, we've got a lot to cover, so I'm going to dive right in. Let me start sharing my screen. And I'm going to share my entire desktop. because I'm going to be jumping between the browser, my terminal, as well as an RDP connection into that Windows machine. If at any point things are too small to see, just let Adnan and Ryan know. I can certainly try to zoom in and make things a little bit easier. Like I said, we're starting from scratch. No Bindplane account, no Bindplane collectors, as if you are literally starting from zero today. So we're at app.bindplane.com, and we're going to go to sign up. We're going to give it an email address. Give it a password and hit continue. I'm going to get that verification link in just a second. Perfect. Already come through. Verify that. Back to Bindplane. I'm going to return to the login. Put in that same password. And I'm going to give it an org name. So we're just going to call this April SecOps webinar. Accept the EULA, it gets started. Literally that quick, we have a brand new Bindplane SaaS instance ready to go. Of course, there's no agents, there are no configurations, but the management console is ready for us to start installing some agents. So let's do that. Like I said, we've got a Windows server and a Linux server that we're going to roll out that Bindplane collector to. So the natural place to start, install your first agent. So let's click that. I'm going to zoom in a bit. And you'll see we have a variety of platforms that you can install the collector on. Linux, Kubernetes, Mac, Windows, OpenShift. And this is pretty much any flavor of containerized, Kubernetes. It's available. But for this webinar, we're focusing on Linux and Windows. So we'll start on Windows. And we're going to stick with the stable version 1. Hit next. All right. And so the installation for the collector is simply an MSI file. We're going to copy this entire command and run it in Windows, but I want to call a couple things out first. Let me keep zooming in here just to make it extra easy for everyone. So, like I said, for Windows, this is a simple MSI file. This can be rolled out basically any way you would normally deploy a Windows MSI file. Nothing special or complicated there. The most important parts are we need to make sure that we're providing the op-amp endpoint, right? That is the URL for the management console. Because we're using SaaS, we're going to point to our SaaS instance. But if this were self-hosted, you'd have your own URL there. And then the other important one is our op-amp secret, right? So this is the shared secret between the collector and the Bindplane server so that they can authenticate and communicate with each other. There are other variables that can be included. We support adding custom labels at the time of installation. You can also apply an existing configuration. But for now, this is all we need. Our MSI file, the op-amp endpoint, and our shared secret. We're going to copy this. We're going to go over to our Windows machine. We're going to go into PowerShell, and specifically, we want to make sure we're running as administrator. So we'll hit next. Perfect. Come in here, paste that command, and hit enter. Now again, for the purposes of this demo, we're rolling it out using the command. Obviously, in a larger organization, if you're rolling out to hundreds, thousands of machines, you're going to use some other tool to push out that MSI file. And if we hop back over to Bindplane, we can see it's already connected into Bindplane, and it's ready to go. If I return to all agents, we've got our first agent there ready to be configured. I'm going to pause real quick because I realize I'm saying the word agent and collector interchangeably, and I want to make sure that that's sort of understood. you'll often hear us refer to the Bindplane collector using a variety of terms: agent, collector. Pretty soon, it's going to be a gateway as well, with one of these configurations we're going to do today. At the end of the day, we're talking about the exact same software, the exact same service running on these machines. We're just using different terms to talk about the exact same thing. And the reason that's sort of important to note is sometimes agent has a very specific sort of connotation. People are assuming a very specific thing. And the Bindplane collector can act as a traditional agent, like it's going to on this Windows server, meaning it's collecting local files, but it can also act as a more general purpose collector, collecting data from remote APIs, such as Azure Event Hub or AWS CloudWatch, those types of things, or collecting data from syslog servers. So again, just want to make sure we're all clear on the terminology. Cool. So we've got our Windows server ready to go. Let's go ahead and get our Linux server up and running as well. So we're going to go right back to our install agent. I'm going to zoom right back in, select Linux, next. And this should look very similar, because it is. Instead of an MSI file, we've got a Linux package, and we provide a shell script sort of wrapper around it. That shell script is really doing things like checking for some prerequisites, things like that. But at the end of the day, it's not technically required. And again, you're rolling this out the same way you would roll out any Linux package. And you should note, it has the same parameters as the Windows installation. We've got our op-amp endpoint, and we've got our shared secret between the two, as well as the ability to add additional labels to identify the collectors or group the collectors, things like that. Cool, let's copy it. We're going to jump over to our terminal, paste, and run. In this case, it's actually going to pull down that shell script and Linux package directly from GitHub, but it would be possible to pull those files down ahead of time and install them from a local source as well. It doesn't technically need that dependency on GitHub. Cool. Hop over. Right back to, we've already got that agent connected. We'll return to agents, zoom back out a bit. And there we go. We've got both our Linux and Windows server ready to go. Collectors installed, but no configurations. So that's where we got to go next. We're going to hop over to configurations, and we're going to start with the Windows server. We're going to create a configuration. We're going to name it something nice and simple, Windows Server. Obviously, you can get much more creative or specific in your environment. This is a simple demo. We'll keep the name simple. And this configuration is specifically going to be for Windows machines. Let's hit next. As I mentioned in the agenda, we're going to collect data from the event tracing for Windows source. This is a brand new source for us and for OpenTelemetry in general. So we're really excited to offer that. Just to give you guys a sense, again, there's a lot of sources. Some of these are local data collection. Some of these are remote. Some of these are pull-based. Some of these are push-based. There's a wide variety of ways to get data into the Bindplane collector. All right, so I'm just going to keep scrolling. These are all well documented in our documentation, so feel free to check that out after the fact to learn more. But here's the one we care about: Windows event tracing. Right. This is, I'm not going to go in depth into sort of how this works, but this is very similar to your traditional sort of Windows events, but it does make certain sources available that aren't available as subscribable channels within the traditional sort of Windows events. And one of those, the one that we are probably most excited about, is the ability to get the Windows DNS server logs, specifically the query logs that are traditionally found in the analytics channel. So ETW will allow you to pull those logs, whereas previously they're not available. They're not a subscribable channel in the Windows event. So we can put in the Windows DNS server as a provider. There are a ton of different providers that are available. We're going to focus on this one today because, like I said, I know it's a common ask. But just so you guys know, you could include a list of providers here. We're going to do the enable raw logs. Again, if you've seen any of our previous webinars, you'll know that this is a really common configuration whenever we're talking about SecOps. We are sending unstructured, unparsed data to SecOps, and then SecOps is going to use their built-in parsers to properly parse that data into their UDM structure. So we've got our option, we've checked it, we've got our provider. Everything else is good to go. We're going to leave the rest of these defaults alone. Let's hit save. Again, we could add more sources here. We could add the standard Windows events if we wanted to, as well as, say, local file logs. But for the sake of this demo, we're going to keep it simple, and we're going to do Windows event trace. Let's hit next. All right. And again, our eventual goal is to get this data into SecOps. Our intermediate goal is to get it through Bindplane Gateway to SecOps. But to start, we're going to actually send this data to a destination called dev null, which basically means we're just going to drop the data. I like to start with dev null because it allows us to get familiar with the data, to tune our processors, and basically just to make sure everything looks the way we expect it to look before we start sending a bunch of data into SecOps or any of our downstream destinations. So we're going to start with dev null. We're going to hit save and save. Awesome. We've got our very basic, simple configuration pipeline. We need to attach it to an agent, right? Right now, it's just sort of here defined. I'm going to add an agent. I'm going to select our Windows server. It already filtered it down to Windows because we told it it was a Windows configuration. Excuse me. So I'm going to select that guy and hit apply. Perfect. We've got it down here in our list of agents. For the demo, we're doing one. This could also be 1,000, 10,000 collectors. You can easily attach the same configuration to basically as many collectors as makes sense for your environment. So let's roll that out. Roll out. Perfect. Green is good. No errors. Everything looks good from here. I am going to shift this guy off screen, and I'm going to start just a small script that I've got that's just going to do some DNS queries. Right? It's going to hit the local DNS server that's running on that Windows server, just so we can get some data flowing. I'm going to click into this first processor node, and things are working as expected. The demo gods have looked positively upon us today. So if I expand one of these, we can see that this collector is indeed collecting events from the Microsoft Windows DNS server provider. And you can see what those look like. Right, so this is all of those query data, the actual DNS queries that are being performed against that DNS server. And you can also see that it is as a raw XML, exactly as we intended. We checked that box to keep it in a raw state. So the body of this message has a single raw XML message. Perfect. One more thing to call out. Adnan mentioned this earlier, but it bears repeating. The data does not flow through the Bindplane management console. This data is not flowing through our Bindplane SaaS instance. The Bindplane server, our SaaS instance, is requesting a snapshot of data from this collector and displaying it in the browser. It's not storing it, it's not retaining it. Again, it's just displaying it in the browser to make it easy when you want to come in here and, again, get familiar with the data and maybe start transforming that data. So we're not going to get into all of the processors that are available. Again, sort of give you a quick view of some of the types of things that you can do: deleting empty fields, extracting data, filtering by certain conditions. If we have time, we'll talk about this in a little bit. There's a variety of ways of parsing the data, transforming it, adding fields, copying fields. So yeah, quite a lot of functionality available. And again, the nice thing about having our snapshot and preview window is you get immediate feedback for any changes that you do using those processors, right? As opposed to having to roll that change out, go into SecOps, look at the data. Did you get it right? Did you get your regex query right? What have you? You'll get that feedback immediately. Awesome. So we've got our first pipeline up and running. We know our Windows collection is working. But again, right now, it's just dropping that data. That's perfectly fine. Let's go ahead and get our gateway up and running. So we're going to go back to configurations. We're going to create a new configuration, and we're just going to call this the SecOps Gateway. This is going to run on our Linux machine. So we're going to say it's the Linux platform. Hit next. We're going to add a source. So the source is actually going to be other collectors, right? In this case, that Windows Server collector. But again, it could be tens, hundreds, even thousands of upstream collectors are going to send their data to the gateway, and then the gateway machine or machines will then ship it off to whatever your downstream destination, such as SecOps. And I'll explain in a minute on why you would want to do this. So same list of sources. I'm going to do Bindplane Gateway. Perfect. We're going to be good with our defaults here. We could certainly listen on different ports, but for the purposes of this demo, these are perfectly fine. Another thing to note is this does fully support encrypted TLS traffic. So you can load a certificate and key onto this server and enforce TLS communication from agent collectors to the gateway collectors. Again, we're not going to do that for this demo, but just wanted to call out that it is available. And we're going to leave the rest of these defaults alone for now. Let's hit save. Again, we could have more sources, but for the purpose, this is going to strictly be a gateway, collecting data from other collectors. Let's hit next. And once again, we're going to stick with dev null just to start. We'll eventually add SecOps, but we're going to start with our dev null destination. This is just to make sure everything's working, going back a very sort of systematic approach. Let's hit save. Again, we've got our config ready. We've got to add our agent. Filters down to our Linux collectors. Select, apply, start rollout. Awesome, looking good. The collector is healthy and ready to go. Now, if we click into here, there's no data because nothing is sending data to this machine. So that is as expected. We refresh, nothing's here. So let's start sending some data to this gateway collector. I'm going to switch back over to our Windows server, who at the moment is still sending it to dev null. And I'm going to make a quick change here, and I'm going to actually enable our upgrade to this configuration to our v2 config. All right, and you'll see some changes here. This is a pretty significant sort of improvement to the way you manage these configurations. It also adds a lot of functionality around routing and connectors. We're not going to get into a lot of that in this demo, but just know that this is highly recommended to update all of this to the v2 configuration. So we're going to do that. I'm going to roll that out real quick. Perfect. Couple things that did for us. One, it broke out our pipelines into 3 separate sections: logs, metrics, and traces. For this demo, we're strictly focused on logs, but we do support the ability to capture and process and export metrics and traces as well. So what our goal is to start sending this data to our gateway. So let's set Bindplane Gateway. Now, we need the host name or IP of that server. In this case, in this simple demo environment, I'm just going to use the IP address. Normally, you would have a DNS resolvable host name. You would probably even have a load balancer in front of these and have multiple gateways. We're going to keep things super simple for this demo, and we're just going to send it to that one machine via the IP address. We're going to leave the ports alone. We're going to leave the protocols alone. We do support different protocols for sending that data. And we're also going to leave these sort of default values alone. One quick call out, as Adnan mentioned earlier, all of our destinations have the ability to support a persistent queue, retry and persistent queue. Meaning, if this collector is not able to reach the gateway, it will queue that data for a period of time or a certain number of batches of messages so that it can then replay those once the connection is reestablished. All of that's enabled by default: retries, sending queue, and the persistent queue. So we're good. Let's save this. Awesome. We are going to add that to the gateway, and then we're going to disconnect dev null. We'll just leave it here. It's not hurting anything. But now we want to start sending that data to our gateway. We're going to roll this out. Awesome. So far, so good. We've got connection. Everything, data is flowing. We've still got our messages coming through. The real test is we're going to hop over to our other configuration. So our SecOps gateway. And do we see data flowing? We do. Fantastic. So again, everything's going well. You love to see it. We refresh this. And again, that collector is now sending all of its data to this gateway machine running on our Linux server. And this is going to be the system that ultimately sends the data to SecOps. Now, I mentioned I was going to talk about why would you want to do this? Why care? So there's a couple different reasons. One, it's a way to consolidate and simplify the permissions, the credentials that are needed. So the SecOps configuration requires credentials to SecOps. And so instead of having all of your upstream collectors needing access to those credentials, instead, we can have just this gateway or collection of gateways have access to those credentials to SecOps. It also can make a lot of sense from a network perspective, again, limiting the egress traffic so that instead of all of your collectors needing outbound access to SecOps, maybe all of that's routed through your gateways. And I'm sure there are other reasons. The other primary reason that we see is if your Windows machine or whatever the collector is, if that system is limited in resources, instead of doing any significant processing, transformation, things like that on the sort of upstream collector, the original collector, you can offload that processing to the gateway. They can be dedicated machines, provisioned appropriately that can handle doing large amounts of regex filtering and processing and so forth. Whereas for these guys, the original collection point, we can do just the bare minimum, right, before shipping that data off to the gateway. Cool. All right. We've got our sort of basic pipeline ready. We're collecting our event tracing for Windows events. We're sending it to our gateway, and we're collecting it, and we see that data flowing on the gateway. Now let's do all of the bits and pieces needed to get SecOps up and running. So, couple key components there. One, obviously, we need to set up the SecOps destination. We'll do that in just a second. But before we do that, we want to make sure that this data is sort of ready to be ingested by SecOps. We've already started doing that by making sure it was raw, unparsed data. So we've got step one done. Step two is we need to tag this data with a particular log type. So this is the field that SecOps is going to use so that it knows how to parse the data. So the way we typically do that is we go into one of our processor nodes, we add a processor, and we search for SecOps. This is such an important step that we've given it its own dedicated processor. So our SecOps standardization processor, and we're going to add a log type. Now, quick caveat. So this is all new enough, as in this the event tracing for Windows source, that we're actually still in the process of working with Google to get their Windows DNS parser updated so that it will support this XML raw data format. So in the very near future, you will want to enter Windows DNS, right? Because that's the default Windows DNS parser within SecOps. For now, again, because we are at the bleeding edge of all of this, we're going to actually use their more sort of general purpose Windows XML parser, right? So WinEVT log _XML. So for now, this is going to allow SecOps to parse that data, to actually do some level of parsing on these events. But very soon, we'll get the Windows DNS parser updated so it will fully support these messages. So for now, WinEVT log XML. Namespace, we're going to leave alone. We don't really have any, in this case, special need to update the namespace. We will go ahead and add an ingestion label. And this is just a way to identify the data within SecOps. We've seen customers use this for different regions or data centers or teams, like what team the data is coming from. This can also be useful as a way to identify the host name of the collector that the data is coming from. So lots of functionality here that we could use. We're just going to keep it simple. We're going to call it data center, and I'm in Ann Arbor. So we're going to be the Ann Arbor data center. Let's save this. I'm going to show you exactly what that's doing. So if we scroll down here, remember how I talked about the snapshot and preview? So we immediately see this processor is going to add these two attributes to each and every log message, right? It's going to add a Chronicle log type. Let me expand this a bit. That is win EVT log, and it's going to add an ingestion label, in this case, the data center, which is Ann Arbor. Perfect. So that was
Denton,
step two.
we have a question that's quite interesting for the context here. Could you add custom log types to this processor?
Yeah, so from our perspective, this is just an attribute that we are sending along to SecOps. So if you already have custom parsers in SecOps, you can absolutely add those as attributes here. But yeah, the important part is that parser needs to exist in SecOps with that particular log type. And if so, you're more than welcome to add that here in the standardization processor. Yep, and we know we work with a lot of customers that have a mix of out-of-the-box parsers in SecOps as well as custom parsers. From our perspective, all we're doing is sending raw data with that attribute, and then SecOps can handle the rest. Cool. We're good?
Yep.
Awesome.
Yeah, we have some more questions on the gateway, but we
Okay.
can probably leave that until you're done with that part of the
Yeah,
demo.
let's hold off on that for now, just because I want to make sure we get the sort of end-to-end pipeline in place.
Yeah.
But yeah, great call or great question with the log type. So we've got our first two important parts. We're sending raw unparsed data. We've added our log type. And the third is we want to batch this data, right? We're basically going to group together the data so that at any time we're sending it, it's more efficient, right? And we're actually going to batch it right here before we send to the gateway, right? Because that's going to make that request more efficient. And then it's also going to make the data going to SecOps more efficient. So we're going to go ahead and batch right here. And again, I could add the batch processor here as well. These are both running in the same pipeline. I'm going to add a processor. I'm going to batch. And these batch sizes, we could certainly leave the defaults. We've been doing some testing, and right now I'm feeling pretty good about a 1,000 message batch size. This is going to depend on the size of your data, the volume of your data. Again, I often start with the defaults, but right now I'm just going to go with a 1,000 message batch size and a 200 millisecond timeout. Let's hit save. Let's hit save. We're good to go. So from this side, we're raw data, log type, batching before the gateway. Let's roll this out. Should be good. Awesome. That looks great. Everything's connected. If I come in here, data is still flowing. Our timings look right. Now, let's hop over to the gateway. SecOps gateway. Hopefully data is still flowing in here. Yep. Awesome. And if we scroll down, we'll see, yep, the attributes are added. So they have made their way across, to the gateway. They're still attached to each message. So they're available and ready to go when we send this data to SecOps. So let's close this. The final step in this pipeline is we're going to add the SecOps destination. First, I'm going to upgrade this guy to V2 as well. Not technically required, but highly, highly recommended. It's a much more robust experience working with the config editor. All right, we can close these guys down. Perfect. So let's add a new destination. We're going to do SecOps. All right, we're going to give it, we're going to call this the Bindplane SecOps, just the name for it. Can't leave that. Perfect. So as with all of the others, we're not going to go into each and every detail. This is well documented in our documentation. Couple things to point out. We're going to stick with the gRPC protocol for now, primarily because it's a quicker and easier installation than the HTTPS. That said, there are certain situations where HTTPS makes sense. These are fundamentally different API calls, right? And so they have, there's sort of different caveats with each. For the demo, we're sticking with gRPC, and I typically recommend that for anybody as they're getting up and running. This is our endpoint, but if you are operating out of any different regions in the world, you would want to make sure you have your regional endpoint, or it will not send the data. All right, let's jump over to SecOps and get a couple of these other values. I'm going to make this a little bit bigger. I'm going to go to Settings, and I'm going to get our customer ID. So I'm going to copy this back over to Bindplane, paste it into our customer ID. For authentication, we're going to use JSON. And how that works is we're going to click over to back over to SecOps settings, collection agents, and you can download that JSON authentication file right here. So if I click download, perfect. You can see I've downloaded it many times. I'm not going to open that exact file, but I will show you roughly what it looks like. So this is a sanitized version, but it's going to look something like this. And to get this up and running, we're going to copy this entire JSON and paste it into that field. So I'm going to minimize this. I'm going to grab the real one, copy it, jump back over to Bindplane, and paste it into our credentials. Perfect. So we've got gRPC, we've got our regional endpoint, we're doing JSON, we've copied it in, we've got our customer ID. For a fallback log type, so this is, as sort of the name implies, right? If we don't see that log type attribute in the logs, we're going to add this. Catch-all is a pretty good fallback log type. Again, the expectation is you should pretty much always be adding that log type intentionally to the data. But if anything happens to make its way through this pipeline without a log type, we'll go ahead and add catch-all. All right. A couple of these others to point out. We are going to send a single field. Remember, we have raw XML data in the body field. So that's exactly what we want to send. Single field, send just the body. And real quick, we could add general purpose ingestion labels. Again, this would imply to all data being sent from this gateway. We could also add namespace. Again, that applies to everything coming out of here. We're going to leave our compression. We're going to leave our timeout. And once again, the retry and persistent queue are enabled by default. So if this gateway, for any reason, cannot interact with SecOps, network issue, what have you, it's going to persist that data locally on the gateway. And again, all of that is configurable for how much data you would that the collector can persist based on how large your hard drives are, etc. Cool. All of that's good to go by default. Let's hit save. get one password out of here. Now, once again, we're going to float over this, get our plus sign, route it down here to SecOps. And then we're going to go ahead and disconnect the one to dev null. Again, it's not hurting anything, but we're just going to go ahead and disconnect it. And we're going to roll this out. Perfect. Things are green. That's looking good. Let's make sure we're still seeing data. One password is being very persistent today. Awesome. We still got data flowing, but the true test is we're going to go over to SecOps in just a second, and we're going to actually make sure that we're seeing data in the search. So let's give it a sec to load up some data. Adnan, what kind of questions do we got in our last 4 minutes?
So we have a few that I think are really interesting. First one on this, why did you use winevtlog XML instead of winevtlog without the XML?
Yeah, great question. So the short answer is because that's the one that parses this data currently. There is something that's just different enough about those two parsers, and I haven't personally gone in and compared the two. But the person asking the question is absolutely correct. If you've watched any of our previous webinars or seen any of our other content, if you were using standard Windows events, we do typically recommend the WinEVT-log. That is the sort of default parser for those. But in this case, for this particular data format, SecOps seems to really want WinEVT-log _XML. I'm sure somebody who knows the SecOps parsers better than I do would be able to compare the two and see the difference. But in this case, that's the one I know will work and parse this data currently. Again, with the eventual goal being for these DNS specific logs, we want to get that Windows DNS log type updated so that it will parse those out.
Nice. And then one more thing about the catch-all.
Mm-hmm.
Would those logs be unparsed in Google SecOps?
Yeah, it's a great question. I can't remember exactly what they look like. I think they will be parsed, but in sort of a more generic way. It would be worth testing because I honestly, it's been a minute since I remember what those look like in SecOps in that case. Again, at the end of the day, we always recommend making sure that you've got your log types set so that rarely becomes a thing you actually need. But yeah, it's a good question, and I like I said, I believe they're parsed sort of generally as more of a general message, as opposed to a more specific parser.
Gotcha.
Cool.
And
Real
then one
quick.
more thing, we've had several questions that are around what if the gateway fails? And I think I've dropped a few links to the docs for agent resilience. So if we
Yeah,
can just take a second to just voice that because we have had multiple
absolutely.
questions on that.
Yeah, no, it's a great call. We'll come back to this once this search is done. Two things to point out. One, keep in mind that oops, I clicked on the wrong thing. That each collector, so each agent collector, has its own persistent queue, right? And that's what's configured in this pipeline. So we've got that down here. And the other thing is, as I sort of mentioned, we always recommend having those gateways configured in a highly available configuration. So multiple gateways behind a load balancer is definitely the preferred option. So those are the two things I'd call out. Again, persistent queue on each agent. If the resources make sense, right? Assuming those collectors, those hosts have resources to store that data. If not, definitely make sure you've got highly available. Awesome. And just on time, we've got our data flowing. We can see right where it started. I just searched for raw data using a known value that's in all of those logs. So if we scroll down here, we can see again, this is, sorry guys, one challenge of showing you everything and still making it big enough to see. So you can see, again, this is parsing those Windows events, Windows DNS server, but it's treating those as more sort of general purpose Windows events. All right. Just in the nick of time. We're going to have to remove that Q&A slide, Adnan. I don't think we've ever actually gotten to a Q&A at the end. So I'm glad you're here to answer questions along the way.
I mean, that's also a good thing, having so many questions that you have to jump back and forth and actually um, engage with the audience in this way,
Yeah.
I think is awesome. And I think it's good that we've had multiple attendees here ask directly about the Slack community. So I've shared a few links here in the questions as well for you all to jump in and participate. And
Fantastic.
yeah, I think Denton, amazing job as always. We're sadly out of time. I am going to make sure to jump into all of these remaining questions and figure out a way of reaching out either through the community, to the Slack community, or by email, just to make sure that we go ahead and answer all of them. But for right now, we do have to drop. And yeah, last thing, we will post this recording once it's ready. Once Zoom sends us a version of the recording, we will be posting it on our YouTube. So just jump into youtube.com/@Bindplane. That's our YouTube channel. It's going to be posted there as soon as possible. So at the latest tomorrow. Yeah, and you will also be getting an email with the link to the recording as well. So don't worry, all of it is going to be in your inbox by tomorrow. Yeah, super happy with this. Denton, any final words?
No, yeah, excited to have you all here. Again, there's so much more that we could have gone through. This was really just getting that initial pipeline up and running. We'll be sharing more and more content about transforming that data, reducing that data, all the things. But yeah, hopefully this gives you a better understanding of how to get started.
Awesome. Yeah, thank you, Denton, and thank you everybody joining. And yeah, until the next one, see you in a month.
Fantastic. Take care.